For decades, space travel carried a single label: too expensive to scale. Every launch burned millions of dollars in fuel. Every extra kilogram multiplied the cost. And every mission lived under the same rule: space was only for those who could afford inefficiency. Or so we thought. Because quietly, beneath the noise of rockets and headlines, something different began to take shape. Not a louder engine, not a bigger booster, but a rethink of where power itself comes from and how it's used once you leave Earth behind. This is where AETHER Power enters the story. Not as a miracle, not as a replacement for rockets, but as a challenge to a long-standing assumption that energy in space must always be carried, stored, and consumed like it is on Earth. The first clue appeared in mission designs that looked unusual: less fuel mass, longer operational windows, systems that didn't behave like traditional power-limited spacecraft.
At first, it was easy to dismiss.
Experimental tweaks, clever optimization, nothing revolutionary. But then engineers started noticing a pattern. Spacecraft relying on ether-based concepts weren't just lasting longer, they were planning differently. Orbits that were once impractical became manageable. Deep space instruments stayed active far beyond expected lifetimes. Power budgeting, once the most restrictive constraint, began to loosen. That raised a dangerous question. What if the problem with space travel costs wasn't launch capability, but energy dependency after launch? Traditionally, power in space has meant compromise. Solar panels degrade. Batteries add mass. Nuclear options raise political and technical barriers. Every solution solves one problem while creating another. AETHER Power didn't remove those systems overnight. Instead, it reframed them. Rather than relying on a single energy source, missions began to integrate ambient interaction, subtle exchanges with surrounding fields, radiation, and motion. Nothing exotic, nothing supernatural, just physics being used with a level of precision that hadn't been practical before. And that's where things got interesting. Because when power systems become lighter, missions become cheaper. When missions last longer, costs spread thinner. And when spacecraft can adapt instead of consume, planning changes entirely. Suddenly, the most expensive part of space travel wasn't staying in space, it was getting there. Which means the economic bottleneck began to shift. Instead of asking, how much fuel do we need to survive? Engineers started asking, how little can we carry and still operate indefinitely? That question is still being answered. Quietly, carefully, without press conferences. Because if AETHER Power is misunderstood, it won't fail spectacularly. It will be ignored. And the teams working on it seem to understand that credibility matters more than excitement. What's happening now isn't a breakthrough moment. It's a transition. Design philosophies are changing. Cost models are being rewritten. And space agencies are testing ideas that would have sounded irresponsible a decade ago, not because they're reckless, but because they're efficient. And this story doesn't end with cheaper satellites or longer missions. Because once energy stops being the limiting factor, entire categories of space activity come back into question. And that's where this gets uncomfortable for old assumptions and old economics. So before we declare victory, before we call it a revolution, there's one more thing to understand. AETHER Power doesn't make space cheap. It makes waste visible. And once waste is visible, and when waste becomes visible, it becomes difficult to justify. For decades, space missions were designed around abundance, large safety margins, oversized power systems, redundant mass added just in case. It worked, but it came at a price. Every precaution translated into cost, complexity, and constraint. The industry accepted this as unavoidable. AETHER-based thinking quietly challenges that habit. Instead of overpowering problems, it asks how systems can cooperate with their environment. How motion, radiation, temperature gradients, and orbital dynamics can be leveraged instead of resisted. Not harvested recklessly, but managed intelligently. That shift sounds subtle. It isn't. Because once engineers begin designing spacecraft that assume continuity instead of depletion, the mission timeline stretches. Maintenance cycles change. Replacement strategies shrink. Launch frequency, a major cost driver, begins to slow. And that has a ripple effect no one can ignore. Commercial operators start noticing that the most expensive satellites aren't the largest ones, but the shortest-lived ones. Government agencies begin questioning why entire constellations need replacing when degradation, not failure, is often the real reason missions end. Ether-aligned systems don't eliminate degradation. They slow its consequences, which means something critical happens. Reliability becomes cheaper than replacement. At that point, the conversation stops being about technology and starts becoming about policy, economics, and control. Because cheaper space doesn't just benefit exploration, it changes who gets access. When power constraints loosen, smaller teams can attempt missions that once required national budgets. Universities, private labs, emerging space nations. Entirely new players begin stepping into orbits that were once exclusive. That's when resistance quietly appears. Not from physics, but from infrastructure built around scarcity. Launch contracts, manufacturing cycles, replacement economics. Entire business models assume limited lifespans and constant renewal. Ether Power doesn't attack those systems directly, but it makes them feel outdated. And that's why you don't see headlines yet. Because the real disruption isn't dramatic. It's structural. Missions begin lasting longer than expected. Budgets stretch further than planned. Systems refuse to fail on schedule. And slowly, without fanfare, old assumptions start breaking under their own weight. The most interesting part? None of this requires believing in impossible energy. It requires accepting that efficiency, once ignored because it was inconvenient, may now be unavoidable. And as more missions quietly adopt these principles, not fully, not aggressively, but enough to matter, the question shifts again. Not can this reduce the cost of space travel, but how long can the old way survive if it does? And as that question lingers, the industry does what it always does when change feels inevitable but uncomfortable. It slows down.
Not openly.
Not deliberately, but through caution disguised as prudence. Through extended reviews. Through further validation required. Through waiting for someone else to go first. Because if Ether Power proves itself quietly, without spectacle, it forces a reckoning. A reckoning with decades of design philosophy built around consumption instead of conservation. What happens when spacecraft are no longer power-starved? Navigation systems can stay awake longer. Instruments don't have to cycle off as often. Data is gathered continuously instead of in windows. That consistency alone transforms science. Patterns become clearer. Anomalies don't hide between gaps. Long-term phenomena finally get observed as long-term, not sampled fragments. And then there's deep space. Out beyond Earth's orbit, power scarcity has always dictated mission death dates. When batteries fade and panels weaken, the silence begins. Entire probes become ghosts, not because they stopped working, but because they ran out of permission to operate. Ether concepts challenge that inevitability, not by cheating energy balance, but by reducing how aggressively energy decays into unusable forms. Less waste heat, less idle draw,
Smarter cycling.
fewer moments where systems demand full power all at once. Individually, these improvements sound incremental. Together, they add up to something disruptive. Because a spacecraft that doesn't rush toward its end changes how missions are imagined. Instead of racing against time, planners start designing for patience. For observation instead of extraction. For longevity instead of replacement. And patience in space economics is a superpower. The cost curve bends slowly at first, but once it bends, it rarely snaps back. Fewer emergency launches. Fewer rushed redesigns. Fewer billion-dollar replacements built on artificial deadlines. Which leads to an uncomfortable truth. The biggest driver of space cost isn't gravity. It's urgency. Ether Power doesn't remove gravity. It removes panic. And when panic disappears, so does a large portion of the expense. So as testing continues, quietly, cautiously, the world waits for a signal. Not an announcement. Not a press release. Just evidence that refuses to go away. And when that evidence becomes impossible to ignore, space travel won't suddenly become cheap. It will simply stop being wasteful. And that may be the most disruptive change of all. This story and movement, in this case, doesn't look like acceleration. It looks like persistence. Missions quietly extended beyond their expected lifetimes. Systems performing a little better than predicted. Budgets closing with unused margins, something almost unheard of in space programs. None of this makes headlines, but inside engineering teams, it changes tone. Confidence replaces contingency. When power becomes predictable, risk models soften. Designers stop overbuilding just in case. Instead, they optimize for balance. That subtle change reduces mass. Reduced mass reduces launch cost. And lower launch cost feeds right back into opportunity. This is how compounding works in space, slow at first, then undeniable. Ether Power doesn't present itself as a finished solution. It behaves more like a framework, a way of thinking about energy flow and environments where every what must justify its existence. And frameworks don't announce themselves loudly. They spread quietly until suddenly everyone is using them. That's why the most important shifts aren't visible on rockets, but in spreadsheets. Cost per day in orbit begins to drop. Cost per data point follows. Cost per mission objective shrinks. And once that trend starts, space stops being an elite destination and starts becoming infrastructure. Navigation networks expand. Research platforms stay active indefinitely. Supply missions become optional instead of mandatory. Entire industries, communications, climate monitoring, planetary science, benefit without ever mentioning Ether by name. That's the paradox. If Ether Power succeeds fully, no one will talk about it. It won't be branded as a revolution. It won't be credited as a turning point. It will simply become the way things are done. And perhaps that's intentional. Because the most transformative technologies in history weren't the loudest, they were the ones that removed friction so completely that we stopped noticing they were there. Electric grids, GPS timing, data compression, all invisible, all essential. So the story doesn't end with a launch or a landing. It continues in mission briefs rewritten with calmer language. In engineers planning 10-year operations without hesitation. In budgets that finally stop treating space like a constant emergency. And somewhere inside those quiet changes, a once unthinkable idea settles in. Space was never too expensive. We just didn't know how to stop wasting energy. And until every mission reflects that understanding, this story still isn't finished. And that realization reshapes more than missions. It reshapes mindset. When engineers stop fighting limitations and start designing around them, creativity takes a different form. Instead of asking how to overpower problems, teams ask how to align with the environment they're entering. Space stops being an enemy to conquer and becomes a system to cooperate with. That shift is subtle, but powerful, because cooperation scales. Once a spacecraft learns to live within its energy means everything downstream benefits. Thermal control becomes easier. Structural stress decreases. Component fatigue slows. Each subsystem quietly thanks the others for not demanding more than necessary. This is where Ether Power's influence becomes difficult to separate from good engineering itself. Was it the technology that extended the mission? Or the philosophy it forced designers to adopt? In truth, it's probably both. And that's why you won't find a single moment where everything changed. There is no switch being flipped. No dramatic before and after photo. There is only a steady accumulation of small decisions, each one favoring efficiency over excess, patience over urgency. Over time, those decisions add up to a different kind of space industry. One where sustainability isn't a buzzword, but a requirement. One where longevity is planned, not hoped for. One where cost reduction is a consequence, not the goal. As this mindset spreads, it reaches beyond orbit. Ground systems adapt. Manufacturing prioritizes durability over speed. Training shifts from crisis response to long-term stewardship. Even mission success metrics evolve from did it work to how long did it keep working well? And somewhere in all of this, Ether Power quietly does what disruptive ideas often do best. It disappears into the background, not because it failed, but because it became obvious. Yet, for now, the story remains unfinished. Tests continue. Assumptions are challenged. Skepticism remains healthy, and validation remains necessary. That's not a weakness. It's how progress stays real. So the movement forward continues without a final chapter. No grand conclusion. No closing statement. Just a steady drift toward a future where space isn't defined by how much energy we can spend, but by how wisely we choose to use it. And wisdom, unlike speed, doesn't announce itself. It reveals itself gradually, in choices that look conservative at first glance, almost boring. Fewer components. Simpler paths. Systems designed to fail less often because they demand less in the first place. From the outside, it can look like stagnation. From the inside, it feels like confidence. This is the phase AETHER Power seems to be entering now. Not the spotlight phase. The digestion phase. Teams quietly adapting what they've learned. Stripping away what isn't essential. Keeping what consistently performs. The technology stops being treated as an experiment and starts being treated as a constraint, something future designs must account for, not argue with. And constraints are powerful. They force clarity. When energy is no longer squandered, mission objectives become sharper. Instruments are chosen more carefully. Data is prioritized more intelligently. Even timelines become more honest. There's less rush to do everything now, and more focus on do the right thing well. This is how exploration matures. And it leads to a question that hasn't been fully voiced yet, but lingers beneath every planning meeting. If space can be operated sustainably, what should we be doing up there at all? That question changes the narrative completely. Because once cost drops and endurance rises, motives are exposed. Are missions designed to understand, or to rush results? To build infrastructure, or to extract value quickly? To observe patiently, or to satisfy quarterly expectations? AETHER Power doesn't answer those questions. It removes the excuse of limitation. And when limitation fades, intention becomes visible. That may be its most disruptive consequence. Not cheaper missions. Not longer lifespans. But accountability. And as long as that accountability continues to surface, as long as energy efficiency keeps reshaping decisions quietly, steadily, this story remains in motion, unfinished, unresolved. And this is where the story finally settles, not with a breakthrough headline, but with a recalibration. AETHER Power didn't make space effortless. It didn't erase physics. And it didn't turn exploration into science fiction. What it did was something far more meaningful. It changed the question. For generations, we asked how much energy space travel would cost. Now we're learning to ask how much energy it actually needs. That shift, from excess to intention, from urgency to efficiency, is where true progress takes root. Not in louder engines or grander promises, but in systems that last longer because they waste less. In missions that succeed quietly because they're designed to endure. The future of space won't be defined by one invention. It will be defined by a mindset that treats energy as a responsibility, not a commodity, that values sustainability over spectacle, and that understands the most powerful advancements don't shout, they persist. So if space travel once seemed too expensive, it wasn't because it had to be. It was because we hadn't yet learned how to stop wasting power. And now that lesson is finally being absorbed, the cost of reaching space may never be what it once was again.